Okay, so for this question, we're looking to find the equivalence point when we're reacting sodium hydroxide with HCl. So this is a strong base with a strong acid, which is going to give us a salt and water. So the ratio here is 1:1, and that becomes important a little bit later. So we're given grams of hydrochloric acid per liter of solution, and so when we're converting and looking at equivalence points, we want to make sure that we're in moles. So if we have 1.85 grams, we'll convert that into moles by dividing by the molar mass of HCl. So 1.85 divided by 36.458 gives us 0.0507 moles of HCl. And that's per liter. So we are told that we have 50 milliliters of this solution, so we'll want to convert that into liters. So 50 milliliters, there are 1,000 milliliters per liter, and then we'll use this molarity that we just found. And so there are 0.05074 moles of HCl per liter of solution. And at this point, we can double check. We started off with 50 milliliters of the solution, converted it into liters, and now we've converted this into how many moles of HCl are present in that 50 milliliters. So from here, we want to continue and see how many moles of sodium hydroxide are needed in order to react with this many moles of HCl. And so using our stoichiometric equivalence in our equation, 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide. So then at this point, now we've figured out how many moles of sodium hydroxide we need. The next step is going to be to figure out how many milliliters we need. So our molarity is 0.0850. So there are 0.0850 moles of sodium hydroxide per liter of that solution. And the answer is asking for milliliters. So for every liter, there are 1,000 milliliters. And so if we want to go back and double check, we see that moles of sodium hydroxide cancels here, liters cancel here, and then this is going to be milliliters of our NaOH solution. Okay, so we'll do 50 divided by 1,000 times 0.05074 divided by 0.0850 and then times 1,000. So that should give us 29.847 milliliters. Now if we look at significant figures, we see that there are 3 here, 3 here, and 3 here. So we'll want to round this to 29.8 milliliters. And that should be our answer.